So let's talk about what a vector is. Introduction to vectors. So what these are, vectors are used to represent an object moving a certain distance at a certain angle. So the distance, I'm going to put in parentheses, this is the magnitude. So used to represent an object moving a certain distance, called the magnitude, at a certain angle, which we'll call the direction. Okay. So vectors are equivalent. Vectors are equivalent if I'm going to say regardless of location. Vectors are equivalent regardless of location if the magnitude and direction are equal. If the magnitude and direction are equal. So if they have the same magnitude or distance, length, they go at the same angle, then they're called equivalent vectors. Okay, so we're going to do an example to kind of show how this is true. Where they're going to be different locations, but they may be the same distance and location. So let's say, for example, I've got point A is 2, 4, and point B is 6, 6. So those are the points that the vector starts and ends. So to show that it starts at A, ends at B, I put AB with a line over it, starting at A, going in the direction of B. So that shows that A is the starting point, B is the ending point. And I'm going to, sometimes too, we denote these with U's and V's, bolded. So a bolded U, that's going to be that first vector. And then for my next one, I'm going to have a different vector. C starts at point 1, -1. D starts at point 5, 1. So we have vector CD, and that one we're going to note with a bolded V. Okay, so first let's find the magnitude to see if their magnitudes are the same. So if we're trying to find the length of them, the distance of them, if we have 2 points, what we can do to find the distance of this is the distance formula, which is D equals square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That's the distance formula. Let's also kind of sketch these to see if our answers make sense. So 2, 4, 2, 4 to 6, 6. So going from A to B, so there's vector U, bolded. How I can denote the magnitude is with an absolute value symbol with our bolded U. So it looks like absolute value of U, but it's really means the magnitude of vector U equals, so let's do the distance formula. X2, 6 minus x1, 2 squared plus y2 minus y1, 6 minus 4 squared. So that's going to be 6 minus 4. 6 minus 2 is 4. Squared is 16 plus 6 minus 4 is 2. Squared is 4. Radical 20, which is approximately, well, or even that's 2 root 5. But that should be somewhere around 4 point, let's see, so we can see if this makes sense on our graph. 4.47. From here to here, 1, 2, 3, 4. So the horizontal distance is 4, so that makes sense it'd be a little bit more than that. Okay, so let's do the same thing for V. So for the magnitude of V, we'll do x2 minus x1, 5 minus 1 squared, plus 1 minus -1 squared, So 5 minus 1 is 4, square root is 16. 1 minus negative 1, that's me. A plus 1, 2 squared is 4, and I get the same thing, square root of 20. 2 root 5, which is about 4.47. Let's see, we didn't graph that. Let's graph that to see if that makes sense. 1, negative 1, and then 5, 1. So that looks about the same distance. Okay, so that's vector v. So now let's see if they're the same direction. So we just found it's the same magnitude. Now let's check out the direction. So for each of these, to find out the direction or the angle, I already started drawing kind of like a triangle on this one. This would be this, the x value right here and the y value of the difference. So it's kind of what we just did here. 6 to 2, this x value. Between 6 and 2 is 4. Here, between 6 and 4 is 2. So we can find that angle by doing tangent. Tangent of theta, I'm finding the angle right here, is 2 over 4. So tangent inverse of 2 over 4 is about 26.6 degrees. So check that out. Tangent inverse of a half, or 2 divided by 4, 26.6. Okay, so that was for u. For v, let's check this out. So between 5 and 1 is a distance of 4. Positive 1, negative 1 is a distance of 2. So actually it's sort of exactly the same. So I'm going to do tangent inverse of 2 over 4 again. And again, I get the same angle, 26.6 degrees. So since they have the same magnitude, same direction, we could say that vectors u and v are equivalent. Equivalent vectors. It doesn't matter where they're located. The other thing I want to point out, notice too, we didn't do it this way since we're kind of doing trig, but the slope of this line, rise over run, up 2 over 4. Slope is 2/4, or 1/2. Same thing right here. Slope is up 2 over 4 to get between the points. Reduce that to 1/2. So same slope, it also shows that it's the same direction.